Okay. So this problem right here is actually much more simple than most students really seem to think it is. But yeah. So what you're doing here is look at the reaction here, and it has a step one, right? And so I would first, because it says step one, I look at this and is this an acid or a acid dissociation? Yes, it's a two acid dissociation reactions, right? And so this will be the first acid dissociation. That means it's a Ka1. If it is an acid dissociation, that means this right here, which is actually the left side of your equilibrium, and that's a mistake that a student could make, is that they could put the entire equilibrium over here rather than just reporting the right side of it, which is, because you already have the left side reported to you, they've already told you what that is. So all you need to do is literally just disassociate one proton from your acid, right? So you rewrite this, it'll have an NH2 on one of these sides. So in this case, we went ahead and wrote it with NH2 on the left side here. And it's still NH3 plus on the right side because every time you report an acid dissociation, you report it one proton at a time. That's by definition, okay? So it actually is what makes acid dissociations and acid-base reactions very easy to do math for, which is actually very nice. So anyways, you're going to lose a proton. That means you've lost a positive charge, which you'll see that that's now neutral. It was positive. This is NH2 because you lost one H. And it's plus H plus. All these coefficients are always 1, and you only have to do the right side of the reaction. You don't have to do the whole thing. Okay, and so the next one, I don't know why I have that up. And the next one is step 2. That means that's the second acid dissociation, meaning you're losing another proton. This would be Ka2 then, because it's the second one, right? By the way, Kb1, Kb2 would be kind of going the other way on these, gaining a proton onto this, if you're curious. Anyways, so and don't forget though, if you ever do Kas and Kbs, just to remind you, acid equilibriums and base equilibriums, acid-base reactions, all of those go through water if they're aqueous. So they are not directly opposite reactions. They are not directly flipping the reaction. All of them will go through the water equilibrium first. So that means you never can just flip these reactions. That doesn't actually make any sense. Okay? Because it's actually going through water. Okay. So in this case we have NH3 plus, and you see they've given you this part. And it is the product from the previous one, which it should be. That's good. You're going to lose a proton again. So you lose an H plus. That means that you're going to go to NH2 over here, and you're going to lose that plus, and it'll be plus H plus. And that is it. Again, remember that you only have to do the right side of the reaction because they already have given you the left side. They've even given you the equilibrium arrow, so you don't have to put anything there. Okay, let me know if you have any questions or don't understand anything.